Have you ever wondered what life's greatest unsolved mysteries are? Well, in today's video, I'll be telling you about my top 5. Number 5, the WOW signal. On August 15th, 1977, a strong radio signal was detected by Ohio State University's Big Ear radio telescope in the United States, then used to support the search for extraterrestrial intelligence. The signal appeared to come from the direction of the constellation Sagittarius. Astronomer Jerry R. Emmon discovered the anomaly a few days later while reviewing the recorded data. On the computer, he circled the reading and wrote the comment "WOW" beside it, leading to the event's widely used name. The entire signal sequence lasted for the full 72-second window during which Big Ear was able to observe it. Despite numerous follow-up searches and hypotheses, including brief consideration of reflections from space debris and comet hydrogen clouds, the signal has never reoccurred, and no explanation, terrestrial or otherwise, has been confirmed. While some researchers have suggested it could represent an extraterrestrial transmission, its signal occurrence and lack of replication limit the strength of the interpretation. The WOW signal has inspired targeted searches, scientific discussion about rare astrophysical phenomena, and references in pop culture. Interstellar scintillation of a weaker continuous signal, similar in effect to atmospheric twinkling, could be an explanation, but that would not exclude the possibility of the signal being artificial in origin. The significantly more sensitive Very Large Array did not detect the signal, and the probability that a signal below the detection threshold of the Very Large Array could be detected by the Big Ear due to interstellar scintillation is low. Other hypotheses include a rotating lighthouse-like source, a signal sweeping in frequency, or a one-time burst. Emmon said in 1994, "We should have seen it again when we looked for it 50 times. Something suggests it was an Earth-source signal that simply got reflected off a piece of space debris." He later somewhat recanted his skepticism after further research showed the unrealistic requirements that a space-borne reflector would have produced the observed signal. In a 1997 paper, Emmon resisted drawing vast conclusions of half-vast data, acknowledging the possibility that the source may have been military or otherwise a product of earthbound sources. He also stated, "I'm convinced that the WOW signal certainly has the potential to be the first signal from extraterrestrial intelligence." In August 2024, the Planetary Habitability Laboratory published a preprint reporting observations made in 2020 in Puerto Rico, where they conclude that the WOW signal was likely caused by a rare astrophysical event in which interstellar emissions energizing a cold hydrogen cloud caused it to suddenly surge in brightness. Number 4, the Indus Valley Civilization. The Indus Valley Civilization was a Bronze Age civilization in the northwestern regions of South Asia, lasting from 3300 BCE to 1300 BCE. Together with ancient Egypt and Mesopotamia, it was one of the 3 early civilizations of the Near East and South Asia. Of the 3, it was the most widespread. It spanned much of Pakistan, northwestern India, and northeastern Afghanistan. The civilization flourished in the plains of the Indus River and along a system of perennial monsoon-fed rivers that once coursed through the vicinity of a major seasonal river in northwest India and eastern Pakistan. The cities of the ancient Indus were noted for their urban planning, baked brick houses, elaborate drainage systems, water supply systems, clusters of large non-residential buildings, and techniques of handicraft and metallurgy. Mohenjo-Daro and Harappa likely grew to contain between 30,000 and 60,000 individuals, and civilization may have contained between 1 and 5 million individuals. A gradual drying of the region during the 3rd millennium BCE may have been the initial stimulus for its urbanization. Eventually, it might have also reduced the water supply to cause the civilization's demise and disperse its population to the east. The first modern accounts of the ruins of the Indus civilization are those of Charles Mason, a deserter from East India's Company Army. In 1829, Mason traveled through the state of Punjab, gathering useful intelligence for the company. An aspect for this arrangement was the additional requirement to hand over to the company any historical artifacts acquired during his travels. Mason, who had versed through the classics, especially the military campaigns of Alexander the Great, chose for his wanderings of some of the same towns that had featured in Alexander's campaigns. Mason's major archaeological discovery in Punjab was Harappa, a metropolis of the Indus civilization in the valley of Indus's tributary, the Ravi River. Mason made copious notes and illustrations of Harappa's rich historical artifacts, many lying half-buried. Previously, scholars believed that the decline of the Harappan civilization led to the interruption of urban life in the Indian subcontinent. However, the Indus Valley civilization did not disappear suddenly, and many elements of the Indus civilization appear in later centuries. The cemetery H culture may be the manifestation of the late Harappan over a large area of the region of Punjab and Haryana. There's also evidence that suggests the Vedic religion derives partially from the Indus Valley civilizations. As of 2016, archaeological data suggests that the material culture classified as late Harappan may have persisted until at least 1000 to 900 BCE and may have lived alongside the painted gray war culture. Harvard archaeologist Richard Meadow points to the late Harappan settlement of Perak, which thrived continuously from 1800 BCE to the time of the invasion of Alexander the Great in 325 BCE. In the aftermath of the Indus civilization's localization, regional cultures emerged to varying degrees, showing the influence of the Indus civilization. In the formerly great city of Harappa, burials have been found that correspond to a regional culture called the Cemetery H culture. The inhabitants of the Indus Valley civilization migrated from the river valleys of Indus and Ghaggar-Hakar towards the Himalayan foothills of the Ganga-Yamuna basin. Though there is some evidence of what happened to them and where they went, it is still not fully understood in today's day and age. Number 3. What causes ALS? Known as motor neuron disease or Lou Gehrig's disease, is a rare terminal neurodegenerative disease defined by the progressive loss of both upper and lower motor neurons that normally control voluntary muscle contraction. ALS is the most common of the motor neuron diseases. About 1 in 400 will get ALS in their lifetime, with cases being much more common in older people. ALS often presents with gradual muscle stiffness, twitches, weakness, and wasting. Motor neuron loss typically continues until the ability to eat, speak, move, and breathe without mechanical support is lost. At least 50% of people with ALS experience significant changes in thinking and behavior, with 15% of individuals going on to develop frontotemporal dementia. An ALS diagnosis is made based on a person's signs and symptoms, with additional testing conducted to rule out other potential causes. Depending on which areas of the body are affected first, ALS may be classified as limb onset or bulbar onset. Right now, around 90 to 95% of cases are due to unknown causes, and 5 to 10% are due to genetic causes. Other causes could include age, male gender, heavy metals, organic chemicals, smoking, electric shock, and head injuries. When it comes to head injuries, it was found that NFL players were 4 times more likely to get ALS than the average person. This research was conducted by scientists who focused on the long-term consequences of repetitive brain trauma. The study looked at close to 20,000 professional football players who had participated in at least one game between 1960 and 2019. The data showed that professional football players were 4 times more likely than the general population to develop and die from lateral sclerosis or ALS. Because the study covers 59 years, the researchers were also able to make an important connection between the length of a player's football career and their risk of developing ALS. Specifically, the longer someone played football, the greater their likelihood of developing ALS became. Those players who developed ALS played more than 50% longer than those who didn't. When it comes to life expectancy, it is highly variable, but typically 2 to 4 years after the initial diagnosis. Number 2, how gravity works. Gravity is a fundamental interaction which may be described as the force that draws material objects toward each other. The gravitational attraction between clouds of primordial hydrogen and clumps of dark matter in the early universe caused the hydrogen gas to coalesce, eventually condensing and fusing to form stars. At larger scales, this resulted in galaxies and clusters, so gravity is a primary driver for the large-scale structures in the universe. Gravity has an infinite range, although its effects become weaker as objects get further away. Gravity is described by the general theory of relativity proposed by Albert Einstein in 1915, which describes gravity in terms of the curvature of spacetime caused by the uneven distribution of mass. The most extreme example of this curvature of spacetime is a black hole, from which nothing, not even light, can escape once past the black hole's event horizon. However, for most applications, gravity is sufficiently well approximated by Newton's law of universal gravitation, which describes gravity as an attractive force between any two bodies that is proportional to the product of their masses and inversely proportional to the square of the distance between them. Scientists are looking for a theory that describes gravity in the framework of quantum mechanics, which would unify gravity and the other known fundamental interactions of physics in a single mathematical framework, theory for everything. Over the past few thousand years, there have been a lot of people who explored the idea of gravity. In ancient Greece, Aristotle believed that each of the classical elements had a natural place in the universe, which it tends to move toward Earth at the center of the universe. He also thought that the speed of a falling object should increase with its weight, a conclusion that was later shown to be false. While Aristotle's view was widely accepted throughout ancient Greece, there were other thinkers, such as Plutarch, who correctly predicted that the attraction of gravity was not unique to the Earth. Although he did not understand gravity as a force, the ancient Greek philosopher Archimedes discovered the center of gravity of a triangle. 2 centuries later, the Roman engineer and architect Vitruvius contended that gravity is not dependent on a substance's weight, but rather than its nature. In 628 CE, the Indian mathematician and astronomer Brahmagupta proposed the idea that gravity is an attractive force that draws objects to the earth and used the term Guruttvakarsan to describe it. The mid-16th century Italian physicist Giambattista Benedetti published papers claiming that, due to specific gravity, objects made of the same material but with different masses would fall at the same speed. Galileo also broke with incorrect ideas. He developed the concept of reference frame and the principle of relativity. These concepts would become central to Newton's mechanics, only to be transformed in Einstein's theory of gravity, the general theory of relativity. Before 1684, scientists including Christopher Wren, Robert Hooke, and Edmund Halley determined that Kepler's third law, relating to planetary orbital periods, would prove the inverse square law if the orbits were circular. However, the orbits were known to be ellipses. At Halley's suggestion, Newton tackled the problem and was able to prove that ellipses also prove the inverse square relation from Kepler's observations. Newton's Principia was well received in the scientific community, and his law of gravitation quickly spread across the European world. More than a century later, in 1821, his theory of gravitation rose to even greater prominence when it was used to predict the existence of Neptune. In 1846, the astronomers John Couch Adams and Urbain Le Verrier independently used Newton's law to predict Neptune's location in the night sky and the planet was discovered there within a day. When it comes to theories of gravity, there are some. The big one is Einstein's general relativity. Imagine a trampoline and you put a big weight in the middle of it. It would weigh down the center of the trampoline and anything nearby would be pulled in towards the weight. The idea is that mass warps the fabric of space-time, like this causing other mass to follow its curvature. It's complex and hard to visualize, but that's the idea. And that's the idea that we are looking at today. Number 1, how the universe started. The Big Bang is a physical theory that describes how the universe expanded from an initial state of high density and temperature. Various cosmological models based on the Big Bang concept explain a broad range of phenomena, including the abundance of light elements, the cosmic microwave background, radiation, the redshift of galaxies, and the large-scale structure of the universe. The observed uniformity of the universe, which leads to the horizon and flatness problems, is explained through cosmic inflation, a phase of accelerated expansion during the earliest stages. Detailed measurements of the expansion rate of the universe place the initial singularity at an estimated 13.78 billion years ago, which is considered the age of the universe. A wide range of empirical evidence strongly favors the Big Bang event, which is now widely accepted. Extrapolating this cosmic expansion backward in time, using the known laws of physics, the models describe an extraordinarily hot and dense primordial universe. Physics lacks a widely accepted theory that can model the earliest conditions of the Big Bang. As the universe expanded, it cooled sufficiently to allow the formation of subatomic particles and later atoms. These primordial elements, mostly hydrogen with some helium and lithium, then coalesced under the force of gravity, aided by dark matter, forming early stars and galaxies. Measurements of the redshifts of supernovae indicate that the expansion of the universe is accelerating, an observation attributed to a concept called dark energy. The concept of an expanding universe was introduced by the physicist Alexander Friedmann in 1922 with a mathematical derivation of the Friedmann equations. The earliest empirical observation of an expanding universe is known as Hubble's law, published in work by physicist Edwin Hubble in 1929, which discerned that galaxies are moving away from Earth at a rate that accelerates proportionally with distance. Independent of Friedmann's work and independent of Hubble's observations, in 1931, physicist Georges Lemaitre proposed that the universe emerged from a primeval atom, introducing the modern notion of the Big Bang. In 1964, the CMB was accidentally discovered. Over the next few years, measurements showed this radiation to be uniform over directions in the sky and the shape of the energy versus intensity curve. Over the next few years, measurements showed this radiation to be uniform over directions in the sky and the shape of the energy versus intensity curve, both consistent with the Big Bang models of high temperatures and densities in the distant past. By the late 1960s, most cosmologists were convinced that competing steady-state model of cosmic evolution was incorrect. There remain aspects of the observed universe that are not yet adequately explained by the Big Bang models. These include the unequal abundances of matter and antimatter, known as baryon asymmetry, the detailed nature of dark matter surrounding galaxies, and the origin of dark energy. There are plenty of theories regarding what caused the Big Bang. One I found interesting is that the universe cycles through expanding and then shrinking. If time is infinite, then this would make sense if it just kept happening over and over. Let me know in the comments below what